then we'll do power fraction, and then we'll get to the zero law in a second. Again, there's 2 other laws you won't meet till next week, or next year, sorry. So if someone talks about the 7 exponent laws, you're like, wait, we learned 5. That's why, because you'll learn the other 2 next year. Here is the official product law. So I'm going to grab a red pen. What? Why can't I teach you the other 2? Yeah. You're not smart enough yet. Shh. Shh. The law says that x to the n, bless you, times x to the m equals x to the n plus m. X to the n times x to the m equals x to the n plus m. It's what we did last unit. We just didn't talk about it like this because we wanted you to do a whole bunch of polynomial stuff first and know how to do it, and then now let's talk about it. What does it mean when multiplying bases? When multiplying bases, you add the exponents. When multiplying bases, you add the exponents. And I'm going to box add because that's the trick to product law. And it's interesting because product means what? Multiply, but what do we do with the exponents? We add because we're multiplying the bases. So product law is we add the exponents. Why? Well, I waited all last unit for someone to say why. Why, Mrs. Thompson? Why are you adding the exponents? You didn't care, so now I'm going to tell you anyway. Here's the why. So I'm actually going to go to the example first, and then I'll come back to the why. So let's do a crazy one we wouldn't have done last unit. Let's do x to the 4 times x cubed. So we kind of stuck to exponents of 1 and 2 last unit because you weren't quite ready. Now we're going to step it up to stuff like this. So let's go back to look at the y. Well, what does x to the 4 mean? So this is what we did yesterday. It means x times x times x times x. So the first one means x, 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 x. What does x cubed mean? X times x times x. So I'm just going to squeeze that underneath because I won't have room to put it to the side. Well, this is just what we did yesterday, where we took big, long expressions and we simplified them using exponents. So what we have if we combine these, we have x times x times x times x, x times x times x. How many x's do we have? 7. That's why we add the exponents. Because if you had 4 x's and 3 x's, in total you have 7 x's. Absolutely. And if you go through pre-cal in grade 12, you'll do that a lot. There's a whole unit on it. I know, now you're too excited, you can't wait, but. Okay, quotient law. I'm just going to switch colors because I like doing alternate rows and alternate colors. It's my left brain, I can't help it. Quotient law we already looked at that we subtract. Let's talk about why. Here's the official law. It says x to the n divided by x to the m equals x to the n minus m. Quotient law says x to the n divided by x to the m equals x to the n minus m. Can you put that into a sentence for me? So the explanation, how can we word that? When dividing bases, you subtract the exponents. When dividing bases, you subtract the exponents. And I waited all last unit for someone to say, why? Why? Please tell us why. Nobody did, so now I get to tell you and you don't have to care. Let's look at a crazy example we wouldn't have done last semester. Let's look at x to the 7 divided by x squared. Again, we stuck to really low exponents last semester to get you used to polynomials. Now we're going to bump it up. X to the 7 divided by x squared. So let's just talk about that x to the 7. What does it mean? Times, 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 times. How many x's do I need to write out? 7. What does the bottom mean? So what does x squared mean? What does it mean if I expand it and I write it out fully? X times x. If I just gave you this, x divided by x, what's any number divided by itself? Any number in the world. What's 100 divided by 100? Or negative 13 divided by negative 13? Or 17.5 divided by 17.5? Or 1/4 divided by 1/4? What's any number divided by itself? So we call that canceling. We can cancel one of the x's on the top with one of the x's on the bottom because it's equal to 1. What about that second pair of x's? What's going to happen if we divide any number by itself? It's also going to cancel. So what's left on the top? How many x's do we have? That's why we subtract, because 7 take away 2 equals 5. Again, this is called quotient law, and what does quotient mean? What does quotient mean? Dividing, but we end up subtracting. So product goes with adding, quotient goes with subtracting. Show me your thumb so far. I get this, I kind of get this, I don't get it. You have to put it really high. I can't see when it's in front of you. Good. That's all we're going to do today is just practice those two laws. We're going to practice, 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 practice so that they're second nature and you totally get it. Here's a whole bunch of product law examples. Product law says when you are multiplying bases, you add the exponents. When you are multiplying bases, you add the exponent. So 6 cubed times 6 to the 4. I keep the 6. I add those exponents, gives me 6 to the 7. Grab your calculators. We're going to prove these are the exact same thing. So I want you to calculate me 6 to the exponent of 7. So do 6 to the 7. And what we're getting away from is baby calculator use where somebody's typing 6 times 6 times 6 times 6 times 6, 7 times, right? That's why we have a scientific calculator. So again, you're looking for whatever button you had yesterday, either the y to the x to the y, x to the n, x to the space, something with a hat with a caret. Minus 6 caret 7. And you should have that same number. 279,936. You can't really see that there. Everybody got that? No, what we're going to do now is calculate this. So we're going to do 6 to the 3 times 6 to the 4. So you're going to put in 6 to the 3 the same way you did 6 to the 7, but don't hit your equals. Okay, so however you put in the last one, put in this one, but don't hit equals. And then I'm going to hit multiply, and I'm going to put in 6 to the 4. Again, don't hit your equals yet. Now, if the math gods are lined up and the universe is perfect, these should be the exact same number. Bam! There we go. So we're just proving these are the exact same number. We haven't changed the value. We've just simplified it. We've just made it down into less 6s. We've just condensed it. It's called simplifying. What does evaluate mean? Find the number, okay? Let's look at simplify, because I don't think we've actually defined it this unit. What does simplify mean? Could be lowest terms if it's a fraction, yes. What else can simplify mean? Make it shorter, make it smaller. That's generally what you're trying to do in math is make it shorter. Shorter, smaller, more compact, less complex. Can you wait till after the examples, or do you really, really have to go? Okay. As a mathematician, I would never write this as 6 to the 3, 6 to the 4. I would always want to simplify it, because mathematicians, we hate wasting space. We like things to be compact and simple. I'm going to work down the columns as opposed to next, so I'm going to go to the 3 to the 3 times 3 to the 15. We didn't even touch 15 last unit. That was scary, freaky scary. Now it's no big deal. Exponent law says if you are multiplying the bases, what do you do with the exponents? Add them. So I'm going to keep the 3, add the exponents together, gives me 3 to the 18. Did the 3 change? No, so I'm not multiplying the bases. I'm not taking 3 times 3 and making it 9. The base stays the same. The exponents just get added. X to the 4 times x to the 5 is going to be x to the 9. Is it really that easy? Yes, they're really that easy. That's exponent law number 1, product law. 4 to the 6, or 4 to the 4 times 4 to the 6. Again, I'm going to keep the 4. I'm not multiplying it because that's not what the exponent law says. All I'm doing is adding those exponents. 4 plus 6. 2 to the 3 times 3 to the 2. What do I do here when the bases are different? Yeah, we can't simplify using the exponent laws when the bases are different. Okay? Can't use the exponent laws when the bases are different. I'm going to repeat that in case you want that sentence down. Can't use the exponent laws when the bases are different. Okay? We don't have a law to smush it together and make it smaller. So you have some choices. You can put can't simplify. You can put unlike terms, like we did last unit. You can put n/a, so not applicable, or you can just rewrite the question. What you can't do is just leave it blank, because leaving blank tells me, did you know that it was already simplified? Did you not know? So you have to put something down. Can't do is fine, something that shows me you understand those bases need to be the same. Am I going too fast? What is that big black dot? But it was a little tiny dot over here. Doesn't matter. A dot's a dot. We don't care how big it is in math. We just care a dot means multiply. X to the 4 times x to the 5 using our exponent law is going to become x to the 9. Keep the base, add the exponents. Oh my God, negatives. Negative 2 to the 7 times negative 2. Are negatives going to scare us? No. If there's brackets in the question, what do you think is going to be in the answer? Brackets. So I'm going to put the negative 2 in brackets. Okay, brackets in the question means brackets in the answer. I'm going to add the exponents. What's on the second negative 2 that we don't see, but we know it's there? A 1. So this is going to become negative 2 to the 8. Brackets in this one. What's the difference between the brackets and the multiply sign? Nothing. What's the difference between brackets, the big multiple sign, and the little multiplication sign? Nothing. Do we care? No, it all means the exact same thing to a mathematician. Why did we get rid of x? X was great for multiplication. You've been using it since grade 4. Why did we suddenly throw x out? It's confusing because it could be a variable, right? We don't know if x is variable in multiplication. This is a straight up product law question that says if we're multiplying the bases, we keep the base and add the exponents. 4. Can we put the brackets? Sure. Do we need to put the brackets? No. Why did I need to put the brackets above and I don't need on this one? Because it's negative. So when there's negatives, you want to keep the brackets. I'll repeat that in case you're a sentence person. If the number is negative, keep the brackets. If the base is negative, keep the brackets. If it's positive, your choice. If you put brackets there, great. If you don't, great. But in negative, you have to have those brackets. Correct. Oh my God, what's going on in this one? There's a whole bunch of 3's here. Are we multiplying? Yeah. So just because there's 3, we don't care. We're just going to add all those exponents together. So 4 plus 5, 9 plus 6, 15, done. That's product law. 2 to the 5 plus 2 to the 2. This is a little tricky one that if you're not paying attention on the test, what you're going to do is just go 2 to the 7. So go back to product law. Product law says when you are multiplying the bases, you add the exponents. Are we multiplying in this one? No. So this, right in between, says we can't do it with this exponent law. We can't just smush them together. So again, you have some choices. You can say doesn't apply, NA, can't do, can't simplify, or you can just repeat the question. I like to just repeat the question. Yeah, again, what you can't do is leave it blank, because if you leave it blank, I don't know, did you know you couldn't simplify it, or did you not know, or what's going on? So you need to put something there. So I'm just going to highlight the last 2 in each column because they're the little tricky ones. They're the ones if you're not paying attention, you're just going through the exponent law question, you're going to totally not pay attention to them. Why is the bottom of the first column, why is it not simplified or not able to be simplified? Because there's different bases. Why is this one not able to be simplified? Because you're adding the bases. And for this, you need to be multiplying. So I'll repeat, this one we can't do because they're different bases. This one we can't do because we're adding in between. Exponent law has to do with multiplication. Show me your thumb on product law. Getting it, kind of getting it, not getting it. Put it up high. I can't see when it's way in front of you. Awesome. Quotient law, and then we'll give you some time to practice. We're not going to do all 5 because then your head will be too full. Quotient law says if we are dividing bases, we subtract. Dividing equals subtraction. Dividing equals subtraction. 2 to the 5, divide by 2 to the 3. Now we don't divide the 2's, and that's what your brain is going to want to do. Your brain is going to want to do 2 divided by 2 is 1. Exponent law says we keep the base. We don't touch it. All we do is subtract the exponents. 5 minus 3 is 2. Why don't we change the base? Why don't we do 2 divided by 2? Well, again, if we go back to what this means, the top means 2 times 2 times 2 times 2 times 2. And the bottom means 2 times 2 times 2. And we know 1 from the top gets canceled with 1 from the bottom. And a second one on the top gets canceled with a second one on the bottom. And 1 on the top gets canceled with the last one on the bottom. So what are we left with? 2 2's. So that's why we can't suddenly make that base 1, because the 2 is still there, and 2 times 2 is just 2 squared. Brackets and negative. Is that going to freak us out? No. If there's brackets in the question, there's brackets in the answer. So I'm going to keep that negative 7 in brackets. All I'm going to do is take the exponents and subtract them. So 10 minus 7. 3. Done. That's simplified. I'm going to put a little asterisk next to this one. What does it mean when I star something and it's in red? Yeah, so when you're the day before the test, you're going through your notes, this has to jump out at you. There's something different for this one. So what I'm going to do is write out the work for this one. We normally don't, but I want to show you with this one what's going to happen. We're going to keep the base. We're going to take the top exponent, and we're going to subtract the bottom exponent. Why are there 2 negatives? Because it was already negative. So in our head, what we're doing is 2 minus minus 4. Put your phone away, please. Mine's not in my hand. 2 minus minus 4. And what's going to happen with that minus minus? Turns into a plus. So this is going to simplify to be 2 to the 3 to the 6. Okay, so when you've got a negative exponent, you might want to write out that step, because when your brain sees negative, it understands. Sometimes when you're just seeing it in your head, you don't. So 2 minus minus 4 means it ends up being adding. Oh my God, x's and y's. We're just going to do them separately. Just look at the x's for now. What's the exponent on top? What's the exponent on bottom? Subtract them. 2 on the bottom, 1 on the top. 2 minus 1 is 1. Do we need to write it? No, I'm just going to put an imaginary 1 so that when you look back, you understand where the exponent went. Y to the 7 minus 8. What is 7 minus 8? Minus 1. And you can have negative exponents. You'll understand what they mean next year, but negative exponents are fine. Okay, so when there's more than one variable, no big deal. We just do them separately. 6 to the 6 divided by 6 to the 4. Quotient law says we keep the base and subtract the exponents. 6 minus 4, 2. 3 to the 2 divided by 3 to the 6. Quotient law says we keep the base. 2 minus 6. Kind of. Minus 4. And again, we can have negative exponents. That's okay. X to the 4 divided by x. Quotient law says we keep the base, subtract the exponents. This is going to become x to the 3. Here's a question from last unit. So here's one that you've already seen. We're just throwing in the coefficients. So when we have the coefficients, we just divide. 25 divided by 5. 5. X to the 3 divided by x. X squared. Okay, so just proving what we did last unit is the exact same thing. Show me your thumb on quotient law. I get it, I don't get it. Good. These are things that just need a lot of practice. This is a fundamental. So if we're talking sport, this is the fundamental. This is how to skate. This is how to throw a football. This is how to kick a soccer ball. You need to practice, 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 practice. How much time does each of these questions take? want you to freak out when you first look at the number of questions that you're going to do. Lauren? We didn't solve like which multiplication example are you talking about? Because the question said simplify, not evaluate. Had it said evaluate, you would already have gotten a number, but it's just not what the question asks. That's simplifying. Just want you to do double the work, one for each hand. You look at it faster. The first worksheet is all product law, so front and back. Again, don't freak out because they're really fast questions. The second sheet is quotient law. I purposely did not give you the answers because it's too easy to look at them, so we're going to correct this tomorrow, which means you have to have it done for tomorrow.